Hello everyone, welcome to another technical video from defaultrouteuk.com. My name is Rich, CCI 24290, and today we're going to just run through a little topic called Proxy ARP. So before we start all that, I just want to bring your attention to our website, defaultrouteuk.com. We have a free membership area here if you guys sign up, and all we need is a username and an email address. We won't spam you, it's absolutely fine. It's all just used to access the site. You get access to all of these great articles. Well, I think they're great because I wrote them, obviously, but you get access to all those articles and some videos, unique content that you wouldn't see anywhere else. And yeah, it'd be great to see you there. All I ask from you isn't so much money, although that's so greatly received. The membership is free. All I want from you guys is some comments and feedback. So read the articles. If you think they're good, then rate them. If you think they're bad, then rate them. I want to just hear about what you think about them. If you want to hear or see anything that isn't up there, let me know. I'll certainly do my best to write articles, do videos on request. I am just one person, but I will do my best. So there's my pitch. I'd love to see you on the website, joining in with the forum and so on. Okay, well that's Default Route UK. On to today's topic. This is going to be Proxy ARP. So Proxy ARP, what's it all about? Normally, I mean, I wouldn't normally use Proxy ARP. It's on by default on a router because historically it was very heavily, well, not heavily used, but it was something that you would see commonly on LAN topologies. The one that I've drawn up today is basically, imagine if you would, you're in a building with two floors, a ground floor and a first floor. And you want to restrict the broadcast domain. So you pop a router in between the two floors, and you've got a /22 on this side. So you got the whole network, which is a /22. That's here, right? 172.16.00/22. So it runs from 00 to 3255. You split it in half, so you're going to have 0.1 to 1.255 on this side. 1.254 on this side, and you're going to have 2.1 on this side to 3.254 on this side. All right. Okay. You're going to split up this layer 3 network into two segments, and you're going to use Proxy ARP because these hosts will have this mask. So the hosts themselves will have a 22-bit mask. The router itself has a 23-bit mask. So what you're trying to do is fool the host into thinking that these hosts here are in the same subnet. So by using the /22, you're going to run from 0.1 to 3.255 usable IP addresses. Okay, sorry, 3.254 usable IP address. So you're going to fool ground floor node here on that IP address to thinking that first floor node here is in the same subnet. And so it's going to ARP out, just like it would do on a local LAN. So on a local LAN, if you want to ping a host that's in the same network as you ARP out to find its MAC address, right? So if I'm a 192.168.1.10/24, and I've got a guy on the same network as me, 192.168.1.11/24, and I want to talk to him, I have to do ARP. I used to use ARP to resolve his MAC address. Yeah, you're all aware about how that works, hopefully. Well, this is Proxy ARP. So the way Proxy ARP works is exactly the same thing. You'll see this host here, which we call ground floor, ARP out for the MAC address of node first floor. So the ARP will be sent out onto this local network here. Proxy router will see that ARP request, and because it knows that IP address 3.1, it'll open up the packet and see that the destination IP address is supposed to be 3.100, and it'll see that it's got a locally connected subnet here on 3.100, which covers that IP address. It will fire an ARP request out from itself now to first floor, which will then see the ARP request, crack it open, realize it's for itself, send back the ARP reply, ARP response. The proxy router will see the ARP response coming from 3.100. It'll make a note of the MAC address from that ARP response associated with the IP address and put it in its ARP table. It'll then fire out the ARP request again from itself back to ground floor. So ground floor will learn the MAC address of proxy router, not the MAC address of first floor, as the destination MAC for 172.16.3.100. And likewise, first floor will learn the MAC address of proxy router's interface here as the MAC address for ground floor rather than ground floor. Okay, so it'll see 172.16.1.5's MAC address is 172.16.3.254's MAC address, because proxy router is going to be doing the proxying. So where have I seen this most used commonly these days? You'd see this on some sort of RAS device, remote access device, like a VPN concentrator or a remote access concentrator, like a PPTT PPTP or LLTP or something like that, you know. Sorry, L2TP sort of router, where you've got a router dishing out IP addresses from your local LAN. Let's say this is a VPN device and you're razzing in. It's going to be offering IP addresses from this subnet to your remote hosts. So as they dial in, they'll get an IP address in this pot. IP address, IP address, IP address. Yeah, and hosts on this local LAN might want to talk to those remote hosts, and in that case, the proxy router will proxy ARP for those IP addresses through itself. So they're not locally attached to this network; they're off net, but it's going to proxy them. So that's where you see it these days. Alright, so I've labbed this up. You can see it's GNS3. I've just fired these on. You can see they're all running. So I don't think they've got any IP address on them. Let me just check the state of these from my template. Oh, they have got IP addresses. They've got IP addresses on here. Let me just check this one. Yeah, that's 100. That's not right. So let me just IP address 192.16. What do we say? 3.100, right? Sorry. So this is the /22 mask, right? So don't forget, the nodes get the /22 mask because they're going to pretend they're in the same network to be able to ARP out. If they were just routing, they would ARP out for the local router. So let's say this was in network 20/23. Let's say that was in that network there, and its default gateway was 3.254, and this guy was in 0. Let's just put that in. Let's say this is in 172.16.00/23. Yeah. And let's say ground floor had a default gateway of 16.0.1, and first floor had a default gateway of 16.3.254, and they were routing each other. That would be fine. You know, that would work. But what we're trying to simulate today is proxy ARP. So we're going to have to. We need them to ARP out. We need them to think they're in the same subnet to find the remote host. Otherwise, they'd just ARP out and find the local host if they were. Sorry, the local router interface if they were routing. Alright, so these have to have the /22, and these guys have the /23. And these have to have the /23, obviously, because we can't have IP addresses in common subnets across different interfaces. If I wanted to put 172.16.01/22 in here and /22 in here, the router would shout at me saying duplicate IP address. You can't do that. You can't have two IP addresses in the same subnet on same interfaces on the same device. Right, so that's first. Let me just check the IP addresses on here. Yeah, that's great. Let me just check the ARP table. Make sure we've not learned anything we shouldn't. Yeah, so all I know about is myself, my local interfaces, and the MAC addresses associated with those. And just check these as well. Show ARP. Yeah, I know about myself and my local MAC, and do show ARP because I'm in config mode. And yeah, I know the same. Let me just check proxy ARP's running on the proxy router. So show interface fast Ethernet 00. Sorry, show IP interface 00. Proxy ARP is enabled on fast Ethernet 00 and fast Ethernet 10. Proxy ARP is enabled. All right, great. So proxy ARP's running. We've checked all the IP addresses. Everything looks good to go. So what we're going to do is going to ping from ground floor to first floor. What it should do is send an ARP request packet out onto the local LAN. Now, that IP address doesn't exist here on this broadcast domain, so it's going to hit the router interface here, and the router interface will inspect that packet, crack it open, and look at the destination IP addresses on a locally attached network to itself. Knowing that, it'll then fire out an ARP request itself to first floor. First floor will pick that up, add the MAC address of proxy router into its routing table, and fire back the ARP response. That'll go back through the proxy router, and then it would pass that on. Sorry, the ARP request goes to the proxy router. Then the proxy router proxies another ARP response back to ground floor. So ground floor should learn the MAC address of proxy router. All right, that's the theory. Let's do it. So we're on ground floor. Let's do a ping for 172. What do we say? 3.100. Yeah. So there's a longer delay than normal, I guess, because we've got there we go. So we've got the response. There's a longer delay than normal because we're doing a proxy ARP here, so it's not the quickest thing in the world. But we see we've got some response there now. So there was the ARP table before. Let's have a look at the ARP table now, and we've learned that 3.100. So make a note. It's not the IP address of the proxy router. It's the IP address of where we want it to go, and it's got a MAC address of CC0B 07160000. Now we expect that to be proxy router's network interface connected closest to us. So let's just do a show int fast Ethernet 00, which should be that one. So CC0B 07160000, and they should match, and they do. All right. So as we thought, ground floor now pinged first floor, got the MAC address for the proxy router, and we shouldn't need to ping back again. As I said, first floor should have seen all of this traffic and made its own mind up about how to populate its ARP table. It should already have that in there, and it does. So using the proxied ARP request through proxy router, it's populated itself to learn that 172.16.1.5, the ground floor's IP address, is that MAC address, and let's just check that MAC address belongs to proxy router, CC0B 07160010, 10, CC0B 07160010. So there you go. So that's all worked out brilliantly. So that's Proxy ARP. I guess that covered that topic. It's quite a short topic. If you guys got any questions, feel free to fire them to me. Go on the website, become a member. It'd be great to see you there. Join the forum. The forum is pretty quiet because we only launched it about a week ago, and it'd be great to see that take off. So, like I say, we're not for profit. We're not a big corporate. We're just for the love. It'd be great to start some decent networking conversations on there and really get that moving. So thank you for your attention, and take care of yourselves. Bye now.